Great. You're good to go.
Okay. Hello, everybody. Welcome to today's REYES session on nuclear physics. My name is Luca Leskowitz. I'm a postdoc at ODU. And today's speaker is Marcus Diefenthaler, a staff scientist at Jefferson Lab. One of the most important aspects currently in nuclear physics is the structure of the proton. The US is investing in the EIC, the electron-ion collider, to study it, and Marcus Diefenthaler is one of the scientists that's developing the program for the electron-ion collider. He is working on the design of this frontier nuclear physics facility and how to process the data with it. He's using AI and modern-day machine learning techniques to be able to grasp all the data that's coming from the detector and then be able to process it. On top of that, Marcus is also interested into transverse momentum-dependent particle distributions. So that sounds like a scary word, but in practice, for a physicist, that is like a picture of how the quarks and gluons are distributed in the proton. So at this point, I'm going to say, Marcus, would you tell us more about your today's topic?
Yeah, thank you. Thank you very much for the introduction. Thank you all for doing enabling ODU REYES, and thanks everyone for attending. So what I will in the next maybe 35 minutes tell you a little bit about Wolfgang Pauli's life. He is one of my favorite scientists, and I will in this talk show a little bit why he is relevant for nowadays science, very relevant for nowadays science. So our journey begins about 200 miles west of Old Dominion University, close to Virginia's Blue Ridge Mountains. I imagine us standing there looking at the night sky, looking at the stars, the Milky Way galaxy, and asking us these fundamental questions our ancestors have asked. What is our role in the universe? Who are we? Where are we coming from? What is our purpose? Science, in particular physics, has played an important role in finding answers to these questions. Questions we ask ourselves in physics is, what laws govern our universe? How shall we know them? And how may this knowledge help us to comprehend the world? In this cartoon, which you see here, you see in a maybe funny way depicted what we nowadays know about the various theories to describe the world. At the time when Pauli was born, our understanding of physics was dominated by classical physics, which is shown on the left. For instance, the laws of motion by Newton's gravity, optics, and a very active field around this time, and still a study of electromagnetic phenomena. We all have likely on our desk next to us a smartphone, and that is all made possible because of studies of electromagnetic phenomena. However, what happened at the time of Pauli was that there was a revolution in physics that happened in the last century. This revolution started with a man named Albert Einstein, maybe the most popular physicist. And he showed in his special relativity, he studied physics at speeds close to the speed of light and how the world completely differs when we are at these speeds. Compared to the speed of light, all speeds which we are familiar with, being in a fast car, being in a plane, are really, really slow. So this is a completely different world. But then understanding this world also helped to solve problems which were there in classical physics, where classical physics failed and could not describe the world. Einstein then immediately moved on and put then out his general theory of relativity, where he showed that he put out a new theory of gravity, how space-time is curved in the presence of big masses. Another important part of this revolution is quantum physics. Quantum physics studies the world at the atomic, subatomic scale. This world is so small that only nowadays with very sophisticated laser apparatus or with particle accelerators, we can study the inner structure of atoms, the inner structure of the nucleon. And this theory, this investigation, that was born in the 20th century. And also there were many surprises how the world at the atomic and subatomic scale is so different than the classical physics we are familiar with, the classical world which we experience. Two pioneers, two unique minds in that exploration have been Albert Einstein, already mentioned him. We received the Nobel Prize in Physics in 1921. Surprisingly, not for his relativity, that's a story of its own, but for one of his other major discoveries, the understanding of the photoelectric effect. The man on the right, younger, was Wolfgang Pauli, subject of this talk, and he received the Nobel Prize in Physics for the discovery of the exclusion principle, which is also called the Pauli principle. Scientists around this time regarded both of them as great minds at equal levels. Albert Einstein was very fond of Wolfgang Pauli. He saw in him his son in physics, and he wanted to have him as his successor for his professorship in Princeton. However, a big difference between them is that even in popular culture, we know a lot about Albert Einstein. Albert Einstein is really well known, he's popular. There's barely anyone knows about Wolfgang Pauli and his life. The reason for that is that his life is more difficult to capture than maybe Albert Einstein's life. And this is a little bit shown here. You see in this picture, Odysseus on his Odyssey, and he's navigating his ship through two sea monsters, Scylla, a large whirlwind, and Charybdis, a hydra with many heads, which was a major threat to the travelers in this mythology. Pauli, in a letter to a fellow physicist, he wrote that between the Scylla of a blue haze of mysticism and the Charybdis of rationalism, there is a path, and this path will always be full of traps, and one can fall on both sides. So Pauli realized, both stuck in his professional life and stuck in his private life, that a sole focus on rationalism is not the path forward. And he balanced this with an enormous interest in mysticism and alchemy, in the role of numbers in science. But this makes it really difficult to capture the complexity of Pauli's science and his private life and his mind in standard biographies. So let us now maybe have a snapshot through that and start that with Pauli's birth. Pauli was born April 25th in the year 1900 in beautiful Vienna, Austria. You see a picture of Vienna in the year, it's a drawing in the year 1900. And on the left, you see him about 2 years old with his mother. His mother, born Berta Camilla Schütz, she was a writer and a journalist. She was not at all a stay-at-home mom. She was a feminist. She was an activist. She was a strong woman. She was married to a successful scientist, Dr. Wolfgang Joseph Pauli, and he can be described in modern terms as maybe one of the first biochemists. They had 2 children. The older one, Wolfgang Pauli, subject of this talk, and then he had a younger sister, Hertha Pauli. She was also an actress and a writer. He had as godfather the also well-known physicist and philosopher Ernst Mach, and therefore he also has a second name Ernst, that is in honor of his godfather. Pauli grew up in a very safe environment, and he grew up in an intellectual academic environment where Ernst Mach and Ernst Mach's philosophy had a really very influential role on young Pauli. He graduated 1918 from Döblinger Gymnasium in Vienna. Gymnasium is maybe comparable to what you call in the US high school. And only 2 months after his graduation, so still 18 years old, he published his first paper on general relativity. That is remarkable because Einstein developed the theory in 1907, 1915. 1915 was his publication on Einstein's field equation. And only 3 years later, an 18-year-old student published a first paper on a theory where at this time people said, oh, only a handful of people understand it. Well, one of these handful of people was this wonder child from Vienna, Wolfgang Pauli. He then went for university. He went to Ludwig Maximilian University in Munich, Germany, and there he worked under Arnold Sommerfeld. Arnold Sommerfeld has an enormous legacy. He had a quite influence on the physicists of that time. 4 of his PhD students won a Nobel Prize. 3 of his postdocs won a Nobel Prize. Sommerfeld himself was nominated 4 times for the Nobel Prize, but never received it. He worked at early theories of quantum of the quantum world together with Niels Bohr in Copenhagen, and he let Pauli study a special problem. People looked first at hydrogen, so he was looking at molecular hydrogen, 2 protons with 1 electron. But also Sommerfeld was really impressed with Pauli's understanding of general relativity. He not only published 1, but 3 papers on the subject. So he asked him to work on a review article. With age 21, Pauli received his doctorate in physics, and he also shortly after his doctorate published his review of general relativity, which in total had 237 pages and is nowadays still available as a monograph on the topic. Einstein, who developed that theory, was blown away by that review article. He said, no one studying this mature, grandly conceived work could believe that the author is a man of 21. One wonders what to admire most: the psychological understanding for the development of ideas, the sureness of mathematical deduction, the profound physical insight, the capacity for lucid systematic presentation, the complete treatment of the subject matter, or the sureness of critical appraisal. Einstein really wanted to meet this young man, and out of that started a friendship between the 2 of them. Pauli then became, and we have a technical problem. I'm sorry for that. PowerPoint just decided to end. We will come back to that when we talk about the Pauli effect, different than bear with me, PowerPoint is loading again. If we have another PowerPoint problem, we have also a PDF to follow up.
Maybe when Marcus figures this out, we see.
I'm almost done.
Sounds good. Let me just tell the attendees that they can put their questions in the Q&A whenever they want. I see some people have their hands raised. So maybe you can keep your hand raised or just put a question in the chat and Marcus will get back to you at the end.
Okay. So sorry for this technical problem. We maybe come back to that when we discuss at the end of the talk the Pauli effect. Now we are back at Pauli, age 21. Where he was very instrumental in the development of the modern theory of quantum mechanics. So he worked first as assistant of Max Born in Göttingen, then he worked with Niels Bohr in Copenhagen, and then for 5 years as professor at Hamburg University. This is a picture of 1927 where many or almost all the people who contributed to quantum theory met and discussed. You see in the center Albert Einstein, who was a severe critic of this new theory. He didn't like its statistical aspects. The only woman which is on the picture, you see her left in the front row, that is the famous Marie Curie. Pauli is here shown in this red box in the back, and his advisors or were here Max Born, and next to him, Niels Bohr. Pauli worked not that he published a lot of papers. He exchanged lengthy correspondences with his colleagues. Among them were Niels Bohr, Einstein, Werner Heisenberg. I will mention Heisenberg in a bit. And he always often excused himself by saying, oh, I have no time to be brief. And he shared his ideas and he shared his results. 2,000 of his letters, that is from the last 10 years of his life, they are available in a book series, very interesting to read. And it's believed that these 2,000 letters are about 2/3 of the entire correspondence which he had. Unfortunately, some of the early letters are not available. Hopefully, maybe one day they get discovered. This is mentioned already, Werner Heisenberg. This is a zoom in from the picture from the Solvay conference. They stand next to each other. Heisenberg was 1 year younger than Pauli. Both have been assistants of Arnold Sommerfeld in Munich, but they have been very different. Werner Heisenberg was someone who went up early. He enjoyed hikes. He enjoyed climbing in the mountains. Pauli was someone who slept until noon. He enjoyed being out in the night. He enjoyed the nightlife. They worked closely together. For instance, Pauli validated Heisenberg's matrix theory of modern quantum mechanics, but they also have been very critical of each other. You see a typical sarcastic comment from Pauli here on the left. Heisenberg claimed that he have successfully developed a unified theory. And this is in a letter Pauli wrote to Robert Oppenheimer, where he writes, this is to show the world that I can paint like Tizian, and he just draw an empty canvas. Only technical details are missing. So he was known for his sarcasm, for his criticism. I would like to illustrate this a little bit on this slide. Richard Feynman, in his autobiography, shared that he was giving a seminar, and when it was time to questions, Pauli, who was sitting next to Einstein, gets up and says, by the way, Richard Feynman is making here fun of Germans and their pronunciation of the English language. I do not think the theory can be right because of this, this, and this. Richard Feynman then says, I wish I had remembered what Pauli said, because I discovered years later that the theory was not satisfactory. So Pauli was right, that it's not the correct theory. He also remembered walking up with Pauli to the library, and Pauli asked, what is Wheeler going to say about the quantum theory when he gives a talk? Richard Feynman said, I don't know. He hasn't told me. He's working it out on himself. Oh, Pauli said, the man works and doesn't tell his assistant what he's doing on quantum theory. He came closer and then said in a low, secret voice, Wheeler will never give that seminar. And it's true, Wheeler then never gave the seminar. And Pauli was very blunt in all of his remarks, even to someone like Einstein. So he wrote a recommendation letter to young physicists, and he said, dear Einstein, I can recommend description of the physicist to you, for he is a capable young man. He has only one fault, namely that he sometimes cannot distinguish between mathematics and physics. But that shouldn't bother you because you've almost reached that point yourself. He was so critical in seminars, and at one seminar, he didn't say anything. So the speaker said, Pauli, why do you have no comments? Do you think you agree with everything I said? And Pauli just shook his head and said, not only was what you said wasn't right, it wasn't even wrong. Or he told to someone, I do not mind if you think slowly, but I do object when you publish more quickly than you think. That all contributed that while everyone agreed that Pauli has a great mind, people also found it a little bit difficult, not only a little bit difficult to work with him. He was also not easy as a teacher. When he gave lectures, he often said, this is trivial, this step is trivial, I don't have to derive that, that's trivial. One student got so frustrated and said, is this really trivial? And Pauli stopped, started walking around the lecture hall, deeply thinking, not saying a word, eventually even leaving the lecture hall, walking around the corridor, coming back into the lecture hall, looking at the student who raised the question and said, yes, that's trivial. And he continued his lecture. That was Pauli in his early years and his personality. His scientific contributions were enormous. 1924, he postulated a new degree of freedom to describe observations, which a year later was identified of the spin of the electron. We already heard at the beginning in the introduction, you heard about the electron-ion collider, you heard at Jefferson Lab. At Jefferson Lab, we now study the spin structure of the nucleon and applications of spin, which are very important for medicine. And this started with Pauli. He then, 1925, published his exclusion principle, which says there's two or more electrons cannot occupy the same quantum state within a quantum system simultaneously. This is a little bit depicted here. So the Pauli principle explains why the structure of matter is as it is. So what you see here is lead, in particular the isotope 208. It has 82 electrons, 82 protons, and 126 neutrons. And one would naively assume that these electrons would be all very much closer to the protons simply because the negative charges of the electrons, the positive charges of the protons, they attract each other, but they're actually quite out. So you see here the shell structure, 2 electrons, then 8 electrons, 18 electrons, 32, 18, and then 4. Very stable configuration, but the reason why this configuration is like that is explained in the Pauli principle. 2 electrons or more cannot be in the same state, and they have to be they have to be different. 1928, he became then professor for theoretical physics at the Eidgenössische Technische Hochschule in Zurich, Switzerland. That's the Swiss Federal Institute of Technology. You see a picture on the side. He also married Käthe Margarete Deppner, a cabaret dancer. This marriage was not happy. It ended in less than a year in a divorce. The same year of his divorce, he postulated a new particle, the neutrino, to explain the beta decay. So beta decay, as it understood nowadays, is a neutron transforms into a proton, an electron, and an antineutrino. But at that time, this was really a complete breakthrough in understanding then the observed energy spectra of the beta decay. And it was also remarkable that he said, well, I postulate a particle which cannot be detected, because at this time in experiments, people were not able to detect the neutrinos. Neutrino was then confirmed 26 years later. Pauli, in his usual way, then said, oh, thanks for the message. Everything comes to him who knows how to wait. At the same time, where he had enormous scientific success with the exclusion principle, his work on general work on quantum theory, also his postulation of the neutrino, he was feeling miserable. He was spending a lot of time, nights, a lot of out drinking, and he had a severe breakdown in 1931, where he then consulted the world famous psychoanalyst Carl Jung. He chose Jung because Jung was really famous at this time, still is, and lived close to Zurich, so it was easy to go to him. And I will talk about this in more detail. I just would like to continue his life. He then married again, Franca Bertram. You see a picture of them where Pauli also shows, you cannot see it on the picture, his Nobel Prize award. This marriage was happy. It lasted until the end of his life. 1939, there was the outbreak of the Second World War. Pauli feared about his safety. I mean, he was of Jewish ancestry, so he moved to the United States, where he worked as professor in Princeton with Einstein. It was also the year where he published the general version of his exclusion principle. It's called the spin statistic theorem, and he has done this work with one of his former students, Marcus Fierz. 1945, the Second World War ended. Pauli also received his Nobel Prize, and he could not wait to return back to Switzerland 1946, where he then also remained until the end of his life. Early already, December 15, 1958, he died of cancer. Pauli's scientific career started with Arnold Sommerfeld, and the Sommerfeld or fine structure constant, alpha S, is approximately 1/137. Pauli was really preoccupied with the question, why is the fine structure constant 137? It's an interesting number. It's a prime number. In Jewish mysticism, 137 means Kabbalah, and it's the boundary between the physical and the spiritual dimension. Pauli realized that the end of his life has come when he was in the hospital and he found out that his room number is 137. I would like to show you a little bit of Pauli's workplaces. So he was born in Vienna, went to Munich for studying. Then he went up there to Göttingen, to change to Copenhagen in Denmark, went back to Hamburg, and then he got 1928 to Zurich. He had to leave Zurich for a while during the Second World War, where he went over the Atlantic Ocean and worked in Princeton, New Jersey, here in the US. But then he returned to Zurich, where he worked and lived until the end of his life. Part of his end of his life was his dialogue with Carl Gustav Jung, which really is on the interplay of physics and the psychology of the unconscious. So let me tell a few words about Carl Gustav Jung. He was 25 years older than Pauli, so he was quite senior to him. And he was with Sigmund Freud, a pioneer of psychoanalysis. He and Freud really showed that the mind is something which can be studied, which can be understood, and also which can be healed. What I found very remarkable about Jung is that he found patterns in different ways of thinking across the whole world, across various cultures. And he saw this as indication for universal primal symbols and images that derive from our psyche, which he called archetypes. And he developed the concept of the collective unconscious that is common to all humankind, and it is derived from ancestral memory. And he was world famous, so European and American high society sought Jung for treatment. Pauli also sought Jung for treatment. A quote here is, "I contacted Mr. Jung because of certain neurotic phenomena which are connected with the fact that it's easier for me to achieve academic success than successes with women. Since with Mr. Jung, rather the contrary is the case," Pauli's sarcasm again, "he appeared to be quite the appropriate man to treat me medically." Well, Jung did not agree with that. He said, when the hard-boiled rationalist came to consult me for the first time, he was in such a state of panic that not only he, but I myself felt the wind blowing over me from the lunatic asylum. Jung immediately realized in the first therapy session a very one-sided intellectual orientation of Pauli and a complete loss of his contact with his emotional life. He refused to do the treatment for him, but what you do is if you have students, you then pass him along his students. So Anna Rosenbaum, one of his young students, he was then asked to treat Pauli and also to document Pauli's dreams. For Jung, Pauli was a treasure trove. In one hand, he was a really great scientist who could maybe help him, so Jung hoped, to find scientific confirmation of some of his theory, but also his dreams were so rich of symbols and archetypes that Pauli really wanted to study them. And after a while, Jung took over and discussed directly with Pauli and analyzed his dreams. Pauli, as a scientist, knowing how to write things down, he documented more than 1,000 of his dreams, and 400 of these dreams are documented in Jung's book, Psychology and Alchemy. You see a picture of this book here on the right. I on purpose pictured a picture of where Jung is discussing the threefold and fourfold universe, because that is something which was very central to both Jung's and Pauli's interest. Pauli was enormously frustrated with Isaac Newton and Immanuel Kant for their emphasis on absolute time and absolute space. And Pauli was really frustrated how they hold up breakthroughs in science, because the breakthrough in science then happened with the special relativity, where Einstein showed, based on work, for instance, by Pauli's godfather Ernst Mach, that there is no absolute time, there is no absolute space, everything is relative. So Pauli, so frustrated with Newton and Kant, he went and wanted to understand how was the work through view before Newton. Well, that brings him to very early phases of science. There's a mystic and scientist, Johannes Kepler, and he saw as fundamental number at the core of the universe 3. That is motivated by Christian theology, Trinity, for instance, and ancient mysticism. But there's also the Rosicrucian Robert Fludd, who saw as fundamental number at the core of the universe 4, and he motivated that by the Kabbalah, by the 4 seasons, by the 4 elements, earth, water, air, and fire. And what both Pauli and Jung noticed in Pauli's science was this transition from 3 to 4. There was a 3-dimensional space, but then the work Einstein and Pauli very much pioneered this also, and other colleagues, they really established a 4-dimensional space-time. There were 3 quantum numbers. Pauli established with spin the 4th one. There have been 3 elementary particles discussed at this time: electron, nucleon, and photon. Pauli postulated the 4th one, the neutrino. We, of course, have now far more elementary particles, but that is where you see the 3 to 4 there. This dialogue is then also published in a book dated together, The Interpretation of Nature and the Psyche, in which Pauli discusses the influence of archetypal ideas on the scientific theories of Kepler. And Jung was very much in his element there, because he was fascinated by the role of alchemy, mysticism, and religion in scientific ideas, and of course also in his psychoanalysis. Pauli was also stuck with the limit of science. He said that quantum theory, despite all of its grandeur, was not a complete theory. You cannot explain with quantum theory biological or mental processes, such as the conscious, which was central in the Pauli-Jung dialogue. He also very much faced the limits of logic. So Pauli argued that a sole focus on empirical falsification, he, for instance, discussed there the work of science philosopher Karl Popper, cannot explain, for instance, how Copernicus got the idea that the Earth revolves around the sun. This was at a time where the opposite was believed, and where people, of course, we all see how the sun is rising and setting, but Copernicus had this idea of the Earth revolving around the sun. So like Einstein in more modern times had the idea that space-time is curved by the presence of massive bodies. This is not coming from logic alone. Pauli also, but also Jung, they really pointed out that it's intuition rather than logic which holds the key to understanding the world around us. Pauli very much accepted this new idea of an unconscious and its connection to it via dreaming. And what happened in there was that there's also a transition from 3 to 4 happening in Pauli's psyche. So he had so far before 3 basic functions in his life and his science: of course, thinking, intuition, and sensation. But in his dream analysis with Jung, he identified the 4th function, the connection of his scientific discovery and his feelings. And by going over this long process, Pauli achieved what is in Jungian terms known as individuation, which is the goal of Jung's analytic psychology. And this is a process where the personal and common unconscious are brought into the conscious. And the result of that is a a balanced psyche. Last point which I wanted to make is you cannot talk about Jung with synchronicity. Synchronicity links Eastern and Western thinking and means the simultaneous occurrence of events which appear significantly related but have no causal connection. Jung very much appreciated that natural laws are built on statistical truths and causality, and of course by that leave out unique or rare events. But he said that in order to understand nature fully, also these phenomena, these events need to be accounted for that fail to fit into statistical models. An example for that is the Pauli effect. So there were numerous anecdotes describing instances in which experiments suffered technical problems in Pauli's presence. That became so severe that one of his colleagues refused Pauli to go into his lab. Pauli himself found this very amusing. At the University of Göttingen, their expensive measuring device failed, and people could not find any reasons for that. And they really wanted to find the reasons because this device was very, very expensive. They noted, well, at least it was not Pauli this time because Pauli was not there. But then they later on found that Pauli was on a railway journey to Copenhagen, and around the time of this accident, he switched trains at Göttingen rail station. And in the book which they published together, The Interpretation of Nature and the Psyche, Jung discusses at length synchronicity, linking the rational world of the suppositional irrational world with intuition and psyche. So we're coming to the end, and I would like to conclude with a description of Heisenberg on Pauli. He said, behind his outward display of criticism and skepticism lay concealed a deep philosophical interest, even in those dark areas of reality of the human mind which elude the grasp of reason. And while the power of fascination emanating from Pauli's analysis of psychophysical problems was admittedly due in some measure to the detailed and penetrating clarity of his formulations, the rest was derived from a constant contact with the field of creative processes for which no rational formulation as yet exists. So what we maybe can take away from that is that we can find answers to these questions, these fundamental questions, what is our role in the universe, in multidisciplinary studies, by diverse groups of scientists and non-scientists from all over the world. Someone who understood diversity and even very much demanded it was Pauli. So he demanded nothing more and nothing less than a new form of science, which he has so far predominantly regarded as a product of the male conscious, and which now urgently needs a supplement that can be described as female or feminine. Pauli is here not neglecting that there are more genders here. He's just simply pointing out things from his own personal experience, and he is making very early the point, which I also would like to emphasize here, that diversity is key, and we need diversity to make progress with all the scientific and non-scientific questions which we would like to answer. Questions brings me now to the final end. If you have any questions, I'm happy to answer. If you run out of time, don't hesitate to contact me, mdiefend@jlab.org, and I will try to reply to you at my earliest convenience. Thank you very much for attending, and sorry for this technical problem, which I will just attribute to Pauli's influence here with some kind of Pauli effect happening here. Thank you.
Thank you, Marcus. That was a very inspiring talk. We have a question from the audience first. So Andreas, please go ahead. Andreas? Okay, perhaps in a bit. In that case, let's go through the question posed. So regarding your the slide where you showed the letters of Pauli, one question is, why do you consider that the letters written between Pauli and other scientists have not yet been discovered or brought to light? Why do you think there are still letters out there we don't know of?
I think because no one made, I think for a very practical reason, no one collected them at this early stage. I think only the letters at his later period were collected, because at that moment it was clear that Pauli is one of the great scientific minds of all time. I attended once a seminar on history of science, and the historian said that we really should never throw our lab books away and never throw our notes away, because this will be all relevant in case we will get one day famous, to really understand our science and document our work. But this often simply happens also nowadays, that people just, they change your position, and some of the notes get lost while moving. And I think that's the sole reason here. One also should not forget that a lot of the stuff happened in Europe during the horrible Second World War, and there was not a priority around this time to keep things in an archive. People at that time, and then they were in Europe, they were with simply.
We have a follow-up question. Go ahead, Judy, please.
Sorry, what?
Go ahead.
Okay. Well, my question is, how intuitions and sensations or feelings can help to discover new science phenomena? Yeah.
Because a lot, I mean, this was exactly the central point of this dialogue Pauli had with Jung. Where is this coming from that people have a certain idea? But this is also related to the sarcastic comment Pauli made on Einstein, where he talked a little bit about the role of mathematics and physics. Mathematics is there. There are a lot of mathematical theories, but not all of them are relevant for physics. Some have a very important relevance. Some have not. And to pick the right ones and to see why is this relevant for a description of nature, that you cannot simply come by logic or cannot calculate. This simply comes out of intuition. That simply comes out of a creative process.
Thank you.
Thank you.
Let's move to the next question in the Q&A session. A student was wondering how to visualize the fine structure constant, and if you are perhaps aware of any links where this can be shown in a nice grammatical way.
So the similar, like we leave fingerprints around, atoms or leave fingerprints around when looking at their spectra. So you can look at a detailed spectra of an atom, but then you can deduce from that, okay, this is this atom. And the reason why these spectral lines are in a certain way, that is, for instance, coming from the fine structure constant. The other remarkable thing about nature is that we have these fundamental theories. One of them is electromagnetic interaction, and they all have constants. And the value of these constants is very important. So the fine structure constant really is in a nice balance compared, for instance, to the size of the gravitational structure or the constant for the strong interaction which bounds the proton and neutrons together, that the world in which we live in is dominated by electromagnetic interaction. Gravity only comes in on our world when, for instance, look at very high mountains which then melt when they reach a different height just because of gravity. So the size of this electromagnetic interaction, which dominates our world, that is given by the fine structure constant. But the word fine structure constant or Sommerfeld constant, this is really coming from the fine structure of spectral lines you see when you look at when you observe atoms in the experiments which were done at that time and analyze them.
We have another question asking you if you are aware of any books that connect quantum mechanics and philosophy, like you did in your talk between Jung and Pauli.
There are many, and I would recommend. Well, I can only recommend what I know, and what I know is more the classical work on that. So there is Heisenberg, for instance, wrote a nice book on the philosophy of quantum theory, and he has the advantage to many other people that he really fully understands quantum theory. In general, there's an introduction to the philosophy of science by Ian Hacking, which I really enjoy. It not only covers quantum theory, it covers all fields of physics, and that is a delight to read, and also relatively accessible.
Thank you. So the next question is, what was the relationship between Feynman and Pauli? Were they friendly or were they competitors?
They were friendly with each other, but also at a level that Feynman was young. He was just finding he was just making his career. Pauli at this time was already regarded as one of the greatest scientists of that time. But they had, apart from that, they not really had much interaction. They did not work closely together. And they know of each other, and Feynman just respected Pauli as the great mind he is or was.
On a similar topic, there is another question asking that Pauli does not receive as much attention from the public as Einstein does, meaning, there's no Pauli t-shirts and there are plenty of Einstein t-shirts. Are you aware of a biography of Pauli that you would recommend to the students?
Well, they're one of Pauli's students, and the name right now escapes my mind. I'm sorry for that. He wrote a scientific biography of Pauli. And that is very interesting to read because it really describes Pauli's work, but this only from a scientific point of view. And a short version of that is actually included in Pauli's Nobel Prize lecture, which is available just on the site for the Nobel Prize. His work with Jung got a little bit in the interest maybe in the last decade. There is a book on the Pauli-Jung dialogue which focuses on dream analysis. And there is a book by a physicist named Arthur Miller, not to mix up with the famous writer, which is called the Cosmic Number, which focuses really on the dialogue between Pauli and Jung. But it's not that there are as many biographies around and as many excellent biographies around as for the case of Einstein.
We have another question here coming about, perhaps this is not your area of interest, but what do you think about quantum turbulence?
What is the question? Quantum turbulence?
Yes.
I'm sorry. I cannot make any comment here because I would not say it's not my field of interest, but it's simply not my field of expertise, and I cannot say anything towards it.
Mm-hmm.
Sorry.
Perhaps another question. Do you know if anybody today is following Pauli's footsteps in this logic of following not just the strict scientific pathway, but also veering into philosophy and psychology? For example, we have UFOs, things that are beginning to be confirmed outside of what we understand. So we may need some, out of the box thinking.
We definitely need some out of the box thinking. And this out of the box thinking is coming into science and science education thanks to a recent emphasis on diversity. Unfortunately, there has in the years and years not been major discussions, at least on the physics side, on these questions, which has a little bit related to what the overall status of physics is, with one of the many fundamental points where we are maybe currently are challenged, or maybe are even are stuck. So I think it would be timely to revisit that. And interesting discussions which in the recent years happened, they're not so much with psychology and physics, but there may be the way other sciences think and how maybe the field of quantum theory or the field of nuclear physics is thinking is emphasizing the role of emergent phenomena. That is something which is very key to biology, for instance. And the idea here is that the world is not dominated by fundamental theories, but there's a hierarchical structure of nature. And at each structure of nature, there are bound states, which typically have less degrees of freedom than the underlying theory has. But there are phenomena emerging out of that. And very simple things. If you look at and an LCD screen, we for instance look at some symmetry breaking, and consequences of symmetry breaking have fundamental consequences in science. An example for that, and this is maybe just now jargon which I put out here, would be the quantum Hall effect or the Josephson effect in physics. And so there are very interesting discussions about that. And there is in the US, in Santa Fe, New Mexico, there's an Institute for Emergent Phenomena which discuss that a little bit in more detail. But I'm not familiar with any new discussions about the role of psychology and physics.
Thank you, Marcus. We have plenty questions more, and I think we could spend the entire afternoon going through them. I apologize, time is what it is, and we're getting towards the end of this session. So I will say thank you, and I will apologize to all the students whose questions we did not get through. Thank you, Marcus. Do you have any last ending words?
Well, I just would like to thank everyone for attending. Thank you very much for your interest in this topic. I'm delighted that there have been many questions. I would like just to emphasize again that feel free to write mdiefen@jlab.org if you had a question, but we simply, because of time, could not answer. And last word, thank you.
Thank you.
Will you stop the recording?
I think I can, although I thought Kevin will. I'm going to take the risk and stop it.